We hope you liked Danny's keynote session, along with Linda's product update, as well as Whitney's keynote demo. In this breakout session, we will be discussing about how to accelerate cloud migration with application visibility and business insights, followed by a quick demo. Now, before we get started, I do want to mention that no part of the material may be reproduced, distributed, communicated, or displayed in any form or by any means, or used to make any derivative work without prior written permission from the company. We will be making some forward-looking statements and talk about what are the upcoming features based on the slides. Many companies are moving to cloud. Cloud migration promises many benefits. The three major benefits are cost reduction, faster digital transformation, and improved customer experience and better performance. Now, based on the maturity of your organization, you may choose one of the three cloud migration strategies. The first one is rehosting, second is replatforming, and the third one is refactoring. Now, in rehosting, you would be doing lift and shift. So pretty much mapping whatever instances you have on-prem or in your data center, you would get the exact same type of instance in cloud and migrate your workload to cloud. It's the simplest of the cloud migration. The second one is essentially mapping some of the components of cloud native services. For example, if you want to move from MySQL to cloud native databases, you can certainly do that by making minor code changes. The goal is to move to cloud faster without making major changes or impact to your application performance. The third one is refactoring, where you're modernizing your application stack. So you would be breaking down your monolith application into various microservices. And this means that you would be leveraging more modern cloud native technologies such as containers, Kubernetes, serverless, and whatnot. So you're pretty much remapping your entire application stack to cloud native services. By far, that's the most hardest, time consuming, and expensive as well. But you would get the benefits of all benefits of cloud. Now, the application complexity is exploding. It's way more distributed, as we know. Simple interaction is not just bidirectional call to your web service, but in the background, it might be touching hundreds of different services, different databases, and maybe even third parties. So it's way more dependent. It's way more dynamic as it leverages containers and microservice technology. So you can spin up and down containers as you scale up and down. But this complexity brings the complexity of monitoring as well. A typical cloud migration process involves various stages. The first one is to identify high impact applications that needs to move to cloud. Now you can do so by identifying applications with most impact to business and least effort of time and energy to move to cloud versus low impact to business, but it takes more time and energy from your ops team. So you will choose the applications that are best suited for your business and cost effective. Then you move to cloud based on the cloud strategy that you have adopted. Could be rehosting, replatforming, or refactoring. Then you validate the migration success step by step. But during this process, things may not work, which will impact your end users and business. And that's when customers would end up buying monitoring solutions or even APM. For successful migration with AppDynamics, we suggest you to engage right after you identify your applications, where you can define baselines automatically out of box for all the metrics that are captured by our agent. As you move towards cloud, we can diagnose and troubleshoot the problems or hotspots associated to your application code running in cloud. You validate the success and you make sure that the application is accessible to your end users and does not impact your business. So you will be able to correlate to your business impact. And then finally, you continue to optimize your code so you can reduce your cloud cost and make your release cycle much faster. Let's find out on how you can do it. When you install the AppDynamics agent, you can automatically discover every component within your application, third-party calls, and the transaction flow. So this gives you a high-level view of how applications interact with each other. You can gain visibility into business transactions that shows how applications are interacted by your end users. Now, our agents are smart enough to generate automatic baseline for all the metrics. So you will be able to identify how the application was behaving before the migration, during the migration, and after the migration automatically. We use Cognition Engine, which is AI/ML based root cause analysis, where based on the baselines derived by the agent, we can automatically identify if there is any anomaly based on the metric and alert on performance issues. For example, in this situation, we see that there was an anomaly detected in checkout, where there was a deviation from a 95th percentile response time, and the suspected cause potentially is the order service, which could be another microservice. So you're able to automatically identify the root cause of the issue and perform automated actions. For example, you can restart a JVM, allocate additional memory, or add additional resources to your application. If you adopt refactoring cloud methodology, you might be leveraging cloud native services such as Lambda in this case. So you can leverage our serverless agent. We support both AWS Lambda and Azure functions. Once you deploy the agent, it automatically maps in this application flow map. So you will be able to see the interaction between different services, upstream and downstream requests flowing between your serverless services as well. You will be able to quickly identify cloud native service bottlenecks, triage, and troubleshoot much faster. If you leverage containers and Kubernetes, you can leverage our cluster agent. We use standard APIs from Kubernetes to capture all the key metrics that you see here, and you can deploy them easily based on either operator, Kubernetes operator, or Helm charts. Now, one single cluster agent can provide visibility into your container, pod, node, and the entire cluster. Now, you are able to correlate to business based on your migration success by easily comparing pre- and post-sale baselines that are automatically captured by our agents. You can validate application, business, and end user impact by looking at the conversion rate. And you can adopt cloud services much faster because you have the visibility and the confidence to move to cloud. With the BIQ dashboards that you see right now, you will be able to compare not just the pre and post releases, but also verify the success of your cloud migration in terms of cost optimization, application optimization, and business optimization. Here in this example, we can clearly see we are over budget on DynamoDB and EC2, but we are under budget for ECR and S3. On the right side, you can see the performance of those respective services, all under one UI. Let's quickly jump into a demo and find out how these things interact with each other. Now, as soon as you log into AppDynamics, first thing you'll see is this application flow map after the applications are instrumented with our agent. You will notice the different interactions that happen across different services. If you leverage cloud native services, in this case AWS Lambda, you will be able to identify the upstream and downstream interactions across different services. In addition to that, you can quickly see a snapshot. So in this case, this dotted line is a baseline, and looks like we are within the baseline limits of the snapshots that we have captured. If there is an increase or decrease based on these metrics, you will be notified. Now, let's take a look into a few other aspects of this platform. I see there is 2.5% error rate, so let me just dive in. As soon as I dive in, I see list of all errors that are captured automatically. So let's open one of these, select reward. You can see that there was an interaction that started all the way from web API to API services, transaction services, credit services, and then finally to reward services. Now it says here, reward item could not be found in database. It means that maybe you're calling a specific reward ID or number, and that's not available in the database. If I drill down, I can see that it was trying to find reward item that could not be found in database. Now let's look at a few other things. Go back here. I change my duration to anomalies. Now if I go under events, I can see a list of events from past, and looks like there was an anomaly that was stored. So let's open that up. Now as soon as I open this up, I can see the graph that shows the first entry point for this anomaly was triggered by reward services, followed by client services, and then transactions. Now using our machine learning, cognition engine automatically identifies if there is any issue related to an application interaction and how it impacts other services. So there was a high CPU spike. If I open this up, I can quickly find out that the average response time went skyrocketing high. And if I scroll further down, I can see there was increase in CPU burn rate, which potentially could have caused issue with the spike in response time. If I want to find out more, I can look at transaction snapshots that are captured by our application. I open this one up. Now I can see the interaction across different services that are automatically mapped based on the snapshot captured by our agent automatically. When there is a bottleneck identified by our application, it immediately captures a snapshot of all the interactions to further troubleshoot in future. For example, so credit service interacting with all these different services. I see a warning sign here, which means that there was warning violation triggered. And if I open one of these up, I can see the stack trace automatically created based on the agent instrumentation. There was an HTTP call that was going out. So it looks like this specific HTTP call took about 99% of the total time. If there are any database related calls, you would see them here. In this case, we don't have a database call. Let's identify this. So this auth service is a Node.js based application. It's using MongoDB. If I go under database, I can see that this specific call was being made. Okay, now that we have found the anomaly, let's jump into some of the infrastructure related information that we capture. So I'm going to go ahead and click on servers, cluster, and I can select one of these clusters. So let's open this one. Now with this, I can quickly identify how my Kubernetes cluster is behaving, if there are any errors associated, number of pods that are running, any threats, any evictions associated to it. I can also see how is the CPU utilization. So this is the max versus the bottom. At the bottom is the one that's being used. If I have quotas assigned, I can see them here as well. If I go under pods, I can quickly identify all the pods that are running within this specific cluster, the namespaces that we are currently monitoring, container IDs, and the host that the specific containers are running in. I can select one of these pods, find out more details. Looks like there was a couch base that's currently been running. And this is the CPU utilization as well as memory utilization. If you want to find more information, you can click on inventory to identify if there was any issues with your cluster in terms of pods, objects, services, and these are the namespaces that we are currently monitoring with our Kubernetes cluster agent. Now deploying this is very easy. You can use your operator or Helm charts to deploy your cluster agent and monitor all the pods and containers natively using Kubernetes APIs. Let's take a look at dashboard quickly. So once I go here, I can quickly identify the Cloud Executive dashboard. Here I can see the user journey that's currently being monitored. I can see if there are any issues with my on-prem services, and looks like there is interaction, and this is the AWS services that have moved to cloud. So it looks like all the services moved to cloud are behaving good. There are some DC services that are being impacted due to poor performance. Few other dashboards, such as this, where we can confirm that pre-migration time was about 6 seconds and post-migration the performance is 500 milliseconds. We can also confirm the conversion rates. The conversion rates have gone up dramatically, I would say about 85 to 90%. So from 48%, it has gone all the way up to 84%. Now that you have seen a quick demo, let's get back into how our customers have used AppDynamics in their cloud migration journey. Now, Wyndham used AppDynamics in their cloud migration journey, and they were able to optimize the performance throughput rapidly during the migration process. They were able to increase mobile booking by 75%, as well as reduce reservation cost by 40%. And as And as Scott Strickland, CIO of Wyndham, said, without monitoring, we would be flying blind. It would be very much manual process. AppDynamics gave us a comfort level we needed during the cloud migration. Here are some of the takeaways from this breakout session. We recommend you to establish an application performance baseline before moving to cloud. This helps you define whether you're doing good or bad after a cloud migration. You can quickly diagnose and troubleshoot with AppDynamics during the migration phase. You can correlate to business impact by validating the cloud migration success using Business IQ dashboards. As next steps, we suggest you to watch Right-Size Your Infrastructure with AppDynamics and Cisco Workload Optimization Manager breakout session. And if you want to learn more about our product, request a demo, or sign up for beta, you can check out this link mentioned below. Thank you.